We are into polynomials, another session where we will be taking up the algebraic identities under polynomials. Let us note down first the identities. The first one being x plus y whole squared. This we have been using for quite long time now. I think you must have learned this in year 7. This is x squared plus 2x xy plus y squared. The second identity is the same with the minus x minus y whole square. That is x square minus 2xy plus y square. Third being x square minus y square, that's giving x plus y and x minus y. Oh, why did I write a 5 there? I'll rectify this with a minus 5. Fourth one being x plus a, x plus b. Will be taking up questions on application of all this. It's x square plus a plus bx plus ab. Here we get into more critical ones, the new ones I think this year. The first three you might have been knowing for quite long, I said. So it's x plus y plus z whole square will be expanded as x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Sixth one is x plus y whole cube. It's x cube plus y cube plus 3x square y plus 3xy square. Seventh being x minus y whole cube. So it is x cube plus x cube minus y cube it will be, as it is x minus y whole cube. So it is x cube minus y cube minus 3x square y plus 3xy square. These are the 7 identities. I think there is one more which is okay, that will be I think x cube plus y cube plus z cube minus 3xyz. This will be x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. These are the 8 identities we will now be taking up questions for. We move on to the next screen. For reference, we can come back to this screen again. Let us take up the first few simple ones of the direct applications. The first question might come across will be like expand each of them with different formulas, identities being applied. The first one I take up is this. We can see, if you recall, it was x minus y whole square formula. So it is x square, the x here whole being root 2x minus 2xy plus y square. 2x square, so this being 2 3s are 6 minus 6 root 2xy plus 3y 3y 9y square. These are all the simple applications. With you might just come across question with fractions in it as well. I take up one such with a similar. It can be 2x minus 1 by 3x whole square. That's giving 2x square minus 2a into b plus b square. So it is 4x square, and this is 2 to 4, but that will give us some 4 by 3, because this x might get cancelled, so minus 4 by 3 plus 1 by 9x square. These are the simple ones. Then come across where it says find the product of these two expressions. Now we see in this question that the one x minus a and x plus a written, so that we apply will be x square, which is 2x whole square minus 3y whole square. So that's 4x square minus 9y square. We now take up one more. See this one. Here it is also, application of x minus a, x minus b, but with a different usage. This is y. This is x plus y by 5 plus 1. Now to do so, if we have to rearrange, and then we know which is our x and which is our y, because if we rearrange, it is x minus of y by 5 minus 1, okay. Then this is x plus y by 5 minus will not be, so it will just be plus. Because this is also giving us a plus, so this will be a plus, because plus minus, that is minus here. Now we see this is x and this whole thing becomes y, so it becomes x square minus this whole y square. So that is x square, and if I expand this 5 by y by 5 plus 1, so it will be x square minus of y square by 25, that is x square plus 2x, so it is 2y by 5 sorry, excuse me, and 1. So the whole thing now becomes, once we remove the bracket, that's giving us some x square minus y square by 25 minus 2y by 5 and then minus 1. Okay, we move on now with more such examples. Again it says find the product of this given expression. We now see how this is done. Look at this portion. This is x minus 1 and x plus 1, that is x minus y and x plus y. That will give us x square minus 1. Then I have the rest of them as it is. Now combine this two. It is a minus b, a plus b. That will give us a square minus 1 square. The rest remaining x4 plus 1. Now if we solve this, I'll get x4 minus 1 as 1, and the other one is again x4 plus 1. This again can be applied as the third identity, that's x minus y and x plus y. So it is x4 square minus 1 square. So that gives us x to the power 8 minus 1. A similar one with fraction we take up here. This is a similar one. This is x minus 1 by x, x plus 1 by x. So x square plus 1 by x square, and then x4 plus 1 by x4. Same, if you see, this is x square minus y square. The rest of them, the rest of the two factors remain as it is. This is nothing here. Now this will give us x square minus 1 by x square. Rest of them I write as it is, but if you look at the first two terms in the brackets, first two brackets, see, it's again we can apply x minus y and x plus y. So it again becomes x squares whole square minus 1 by x squares whole square. The last term remains as it is. So this is x4 minus 1 by x4. So this is x minus y, and this is x plus y. So it is x4 whole square minus 1 by x to the power whole square. So that's giving you x to the power 8, 1 by x to the power 8. That's the answer for this question. Now, applying the identities, we might have to, we might just be asked to calculate or find the value of some arithmetical calculations. Like I take up one such in the next page. Suppose we have to calculate and find out 103 into 97. We need not calculate it directly. It says apply the identities. To apply the identities, we have to give this a format like 100 can be expanded as 100 plus 3. So it is x plus y. Again we try to expand 97 in terms of 100 and 3 both. So it gives you 100 minus 3. So now it becomes a plus b and a minus b, or x plus y and x minus y. So it is 100 square minus 3 square. See, our task is getting not that, though it's getting reduced. Otherwise, you'd have directly calculated. So it is orally can be done 9991. Similarly, if we are supposed to calculate 97 square, how can we express 97? Can be written as 100 minus 3. Try to expand them in terms of hundreds or tens. That becomes easier when we are calculating this squares of them. Here it is 100 square, it is x minus y whole square. So it is x square minus 2 into xy plus y square. So that is 10,000 minus 600 plus 9. 10,000 minus 600 plus 9 will be 9409. This makes our calculations quite easier. Now look at the one here. It is 185 into 185. Minus 155 into 155. This can visibly be written as 185 whole square minus 115 whole square. That's a square minus b square. So this is 185 plus 115 and 185 minus 115. So 185, and this will give you 0, 9, 300, and this is giving us minus 70. So it is 3 7 21. See it, how it makes our task such easier. Otherwise we would have multiplied and then subtracted. We'll take a few more application of identities in the next few sessions. Thank you.